Hello everyone, in this video I'm first going to announce the winner to this week's contest where we had posted this algebra question and invited responses from you to explain the choice that you chose. It's not just about saying A or B, it's about why A, why B, or whatever your choice was. We got some very good responses, thank you for that, but there is something very interesting about the responses. Just look at this data here. You have the majority saying 77% of the people saying that C is the correct answer, y squared less than 1. But the correct answer is E. None of these is going to give you all the possible values of y. So only 11% of all the votes, this was around 300 votes, only 11% of the people got this correct. Now this is exactly what you'll see in the solutions also, in the comments that I show you also. Once I show you that and I announce the winner, we will all go together onto seeing the actual complete solution for this question. Let's start with the comments first. As you see here in the first three comments also, the final answer that people have come up with is -1 to 1, y being between -1 and 1, and therefore y squared being less than 1. Among most of such responses was one response by Bipin Kumar in which he explained everything, the exact solution, how he considered, how he got the question really that it was asking for all the values of y. And ultimately, he also got to this point of y being between -1 and 1. But he did not stop here. At this point, he says, you will find out that it will not hold for 0. If you put 0 in the original inequality, it's not going to work. And therefore, he goes on to say that you have to exclude 0 from this range that you had to get all possible values of y, which was the question. So this is going to be two different intervals between -1 and 0 and between 0 and 1. So Bipin is the only one who captured this here, that the correct answer should be choice E. While Avinash also got to the correct choice, the reasoning here was not correct. So out of all of the comments, we got around 17 comments or so. Only 2 of them came to choice E, and Bipin was the one who explained it perfectly. So Bipin, congratulations, you are the winner to this week's contest. And what you get is 1 month free access to GMAT online. To get how to get this access, to understand how to get that access, just go to the description box and find out the details. For everybody now, let's get into the complete solution to this problem. Now before I start discussing, let me remind you to hit the like button to let us know that you enjoy such videos from us. That'll keep us motivated to create such videos regularly. Let's get started. The question tells us that y is a real number. So it says if y is a real number and the mod of y cubed is less than y squared. Mod of y, or the absolute value of y, you're taking the cube of that and you're taking the square of y itself and you're seeing which one is greater out of these two. The question asks for the choice that gives us all the possible values of y. All possible values. Let's just see what we can understand from this inequality given to us. All we know otherwise is that it's a real number. It could be any kind of a number. It could be negative, it could be positive, it could be a fraction, it could be an integer. We have no information here. Now in this case, you need to understand that if I have any number a whose absolute value I'm taking, then there are two possible values of this absolute value. So mod of a can either be equal to a itself or it'll be equal to minus a. Now when will it be equal to a itself? If a is greater than or equal to 0. Basically in this case, the absolute value does nothing. The number was already non-negative. While the second case is valid if a is less than 0. So if a number a was negative earlier, then when you take the absolute value, it makes it positive by multiplying it with -1. So you see how there are two possible cases whenever you're dealing with absolute values. So in my case also, since I have the absolute value of y, there will be two cases and I will consider both of them. So this is the first process skill we're applying here, which is considering all the cases. Let me write down case 1. Case 1 is what now? If y is greater than or equal to 0. In that case, I'll just rewrite my y, my mod y as y. So the inequality I will get is this. Then it comes to how to solve the inequality. You can first write down both of these on the same side of the inequality like this. After that, you take y squared common, and this is what you end up with. So what I did here is simplified my inequality to see it in a form which I can use to deduce more. What is that more now? Think about it. If I have y squared, the square of any number in the world is either positive or 0. But if this was 0, then the entire product would also be 0. It would not be negative, right? That means in my case, y squared cannot be 0. And the only possibility I am left with is this, that y squared is positive. Now it's the product of two numbers that is negative. If one is positive, then the other one has to be negative for the entire product to be negative. Here I made an inference, right, based on the signs that I know. So overall, I got that y minus 1 is less than 0, which will tell me that y is less than 1. But that is not it. Remember the range that you're in. You are solving for the range where y is greater than or equal to 0. Yes, you now know that y is not 0. You found that through this piece here, but you still have to take care that y is greater than 0. So for us, the complete range, solution range from this first case is this, that y is between 0 and 1. Similarly, let's try to solve the second case, which is where y is negative. In this case now, we will open the absolute value of y as negative y. So this is negative y whole cubed less than y squared. Well, now the cube of negative y will just be minus y cubed less than y squared. Yet again, get everything on the same side. So I can say it's y cubed plus y squared, and 0 stays here. So this is now positive. The same story, you take y squared common. This is what you have, and this is greater than 0. This time I know y is negative. That means my y squared has to be positive. Now the question of y being 0 does not even arise. So for the entire product to be positive, then I can also infer that y plus 1 is positive. Now y plus 1 being positive means that y is greater than minus 1. But is it all of the numbers in the world that are greater than minus 1? No, I have to remember that I'm solving in the range where y is less than 0. So I put that here, and this gives me my complete solution. So you saw in both of them how the solution we got was not enough on its own. We had to apply the constraints that were applicable because of the cases that we were dealing with. Now finally, let me just help you visualize this entire solution on the number line. The first piece here gave us that y is between 0 and 1. So this is 0, this is 1, and y is between these two, not including any of these. That's why I've kept these open balls. The second one is between negative 1 and 0. So yet again, here is an open ball at negative 1, and you take everything in between. Now understand the solution here. It doesn't include minus 1, doesn't include 0, and doesn't include 1. So here we're visualizing the solution. This is all the possible values of y. This is precisely what we're looking for. Now we just have to see which choice gives us that. Right? So let's look at choice 1. Choice A says y is greater than 0. This is definitely not it. Y greater than 0 would have so many other numbers and would not even have this blue region, the one that I have between negative 1 and 0. Similarly, y greater than 1 is wrong. Y greater than 1 is everything here on the right hand side of 1, which is not a part of my solution range. So I eliminate choice B as well. Choice C now says y squared is greater than 1. What does that mean? Well, y squared is greater than 1 happens in two cases. Y itself is greater than 1, or y is less than negative 1. But that is not what I have. Greater than 1 or less than negative 1. These would be these two outer regions, which I don't have in my solution. So choice C is out as well. Then let's look at choice D, which is kind of the reverse of D. This time you're saying y squared is less than 1. Well, this happens if y is between negative 1 and 1. Now this seems right, but there is one problem here, one big problem. Our solution does not include a 0. So choice D is also incorrect, and the correct answer is E. None of the above here give us the complete range of all values of y. So you saw in this solution how at different steps of the solution I used different process skills to get closer to my answer. Started with considering all the cases, then I simplified the inequalities I had, and then I inferred the sign of y minus 1 and y plus 1 using our conceptual understanding of what y squared is, how it is always non-negative. Then finally, whatever solutions we got here, we combined them with the constraints we had, because we had a certain range that we were working on. That gave us the complete solution, which we visualized on a number line. And this number line then helped us properly and quickly eliminate the incorrect choices, leaving us with the correct answer here as E. I hope this clarifies a lot of your doubts that you had in absolute values and inequalities and in inequalities with powers and so on. Process skills are a wonderful way to get you through from your conceptual understanding level to applying those concepts. To stay tuned and get more such content, make sure you subscribe to the channel. We regularly post MBA admissions related content and, as you just saw, content related to GMAT preparation. See you inside. Happy learning.